Example 7, we're going to solve it by factoring as well. Now this factoring process became a little bit more complicated. If we check our greatest common factor, there is no greatest common factor between 12, 16, and 5, and there aren't x's in all of them. It's not the difference to perfect squares, so we're going down to our trinomials. And if it's a trinomial, if it's going to be factorable, it's going to factor into two binomials, so we're trying to figure out what those two binomials are. So I'm going to come over here and I'm going to look at some strategies that we've used throughout the year to help you find those factors. One of those strategies that we try to use is taking our values of a and c and multiplying them together. So a times c is a 12 times a 5, and 12 times 5 is a 60. So this is an important piece of information for us, because what we want to do is we want to be able to generate factors of 60 that will give us, and our next combination, our next link to this is b. We want factors of 60. So think of things that I can multiply together to get 60, whose sum is b. So whose sum is, in this case, is 16. So we want a sum of 16 that we can multiply together to get 60. So I'm going to generate a list of factors of 60. So things I can multiply together to get 60, 1 times 60, but their sum is not 16. So that's what I'm checking. 2 times 30, their sum is not 16. 3 times 20, get closer, but that's not the sum. That's 23. And then I can go 4 times 15, well that's a sum of 19. I can go 5 times 12, and that's a sum of 17. Like I said, we're getting closer. And then I can go 6 times 10. 6 times 10 is 60, and 6 plus 10 is 16. So what we're going to do is we're going to come over here, and I'm going to pick this problem up and complete it by using our strategy that we just applied. We need factors of 60 that add up to 16. And we found those numbers. Those two numbers are, and this is where we break up our 16. This 16x can be broken into our 6x plus 10x. So plus 10x plus 6x, and then plus 5 equals 0. Now these two numbers are interchangeable. It doesn't matter where they go. If you wanted to go like this, you sure can. It makes no difference. You're still going to get the same factorization. I'm just going to take them off and leave that the way it was. Now at this point, you group the first two and you group the last two, and we're fairly fortunate this time that the sign in the middle here is plus. You always want that to be a plus. If it wasn't, you'd make it plus the negative. Now we factor out the greatest common factor of this first grouping, which will be, I can factor out a 2x, and if we factor out a 2x, we're dividing by 2x, and that's going to leave us with a 6x plus 5. Now if it's done correctly, this factor should be the same as this factor over here, and as we notice it already is, and there is no greatest common factor I can take out of 6x plus 5, so I just leave it as 6x plus 5. Sometimes there will be another factor you pull out, and sometimes there won't. And now we finish our factorization by realizing that these two factors are common in our binomial, so we factor out our 6x plus 5, and once we factor it out, what we have left is a 2x, and this is where you got to be careful. Whenever you factor, you're dividing by 6x plus 5. Take another 6x plus 5, and that gives you a 1 back here, so plus 1 equals 0. And this is really a unit of 1. So we got our 6x plus 5 times 2x plus 1 is our factorization. Now that we know what our factorization is, we'll apply our zero factor theorem. If we have an answer of 0, and this time we only have two numbers that equal 0, then I know that the first number is equal to 0 or the second number is equal to 0. By the first number, I'm saying this is our first number, this is our second number. So the 6x plus 5 would have to equal 0, or the only other way that I can get an answer of 0 is if the 2x minus the 2x plus 1 is equal to 0. And we'll solve each of these to help us find that value of x. So I subtract the 5, divide by the 6, that's a negative 5 divided by 6. Or we have a 2x that equals a negative 1, or x equals a negative 1/2. Oops, didn't write that very well. Come back. Negative 1/2. So the solution set for this particular example would be negative 5, 6, negative 1/2. Okay, now that ended the factoring portion of your quiz. It made you use a lot of your different factoring strategies in order to be successful. So it's important that you keep brushing up on those and making sure that you can do each one.